Hello there and welcome back to another day where I have some free time. And in this day's video of unstd-c, we'll be trying to make this C runtime object since we have to have something that will call on the main function of C. Since that's not the usual, that's not the actual entry point of executables but something else that is managed by the C runtime that is from the C standard library. So let us get started. So let's just put that in a folder called CRT or C runtime. And I think that is mainly called CRT0 since, I see it over here that it's the execution startup routine so that it can call the main function. So yeah, let's do it. It's CRT0. And the code for hello shall be the C runtime. And hello will have main with no arguments yet. And this should return, well, 69. Now, we know that RTI is the argument for the syscall, the first argument, and REX is the syscall number. So let's do this in reverse. And I see here in the x64 cheat sheet for assembly that we call on functions via, I think it was called. So by having call, we can jump on a label, which is main. So we have to call on main. And I believe in the system VABI over here that the usual register where it puts the return values in is RAX. But let's see here in the conventions, I think. Or was it in Linux conventions? So the calling convention and for syscalls, Rx contains the result of the syscall. But how about just the normal call? Hmm. Ah, not here. So let's search on return. I see. Well, I don't see it yet. Oh, there you go. In the register usage section, the TRX is usually used as the first return register. So we can move the value from IX instead of having the default value of 69 to RDI. And then we can run the syscall. Though we have to, add this first on the build file. So we can just make this a normal, I would say an executable, but this should not be an executable. It's just an object that has to be linked together with the user's code. So I guess we can use a hack from Nobita on just specifying a command since, it would still compile it to an object file, but it would not link it to anything. So Nobita build add command on B and call it CRT. And we can copy this over here, change hello to CRT, and the source file should instead be the one from the C runtime. Also, we can make hello depend on the C runtime itself. Now, what is the actual part where we use the command? Well, I think in user lib, there's something called the C runtime, but they call it CRT1.o. So yes, we'll be copying that, the result of the compiled object, to our lib folder in Nobita build over here. So we can copy that. So we can set it up, Nobita build, add, well, no, it should be Nobita CMD, add args. And for our C runtime, we have to copy it over from our formatted argument. So Nobita custom command, and we can copy it from Nobita cache. And well, I did this off camera, but I made it so that it would compile in folders named after the build target and what type of target it is. So for custom command, it would be compiled under custom, and then the directory of the actual, well, source file. So it's under CRT, but instead of .c for the CRT0, it's now an object file. And we can get the current executables directory to have the full path to the cache file. And we have to copy this over to the library folder, which we have on getlib. Now over here, we can add a link flag before setting the build tool, since, well, setting the build tool over here adds a few link flags first. So we have to add it before that. So add LD flags. No, maybe it should be a formatted argument for the link flags over here. And we will add the object file. And this should not be CRT but hello. Also, I'm forgetting try rebuild over here. So B and file. But well, we do have to compile this ourselves first. Oh, what do you mean no reference to add command? It's, oh, why is there only one over here? And how did this pass for so long? So I actually misrenamed this, or misnamed. I should commit this change later on the actual Nobita repo, since that is wrong. But let's see if it compiles now. Okay. Then, oh, I see a core dump over here. I believe it's because of this one. Our variadic function that did not end in null. Well, the only exception of this is our formatted arguments that does not have to end in null. So let's try rebuilding this and see that in hello, it exited in 69. Now, how about if I change this? So how about 420? Rebuild, run hello, and no, it's 164. Is there a limit to that, to the exit value? So how about 255? Well, that's the first time I'm knowing about this. But now we have a part of the C runtime. Well, I'm sure there's more to be added here, like how to get the arguments for main from, well, using inline assembly anyways. So that will be our next goal. So pass the usual arguments to main via inline assembly. So that will be our next goal. So thank you for sticking with me this far, and may I see you on the next one.